Hello everybody, welcome to today's live webinar. Thank you for joining us today. I hope you can hear me loud and clear. I'm Michela Fassi, Communication Manager at Milestone, and I'll be your moderator for today's webinar. Today we are here for our live webinar titled Tips and Tricks for Microtomy. In this educational webinar, we will see some valuable tips on how to avoid the most common pitfalls and achieve a successful cutting at the microtome. Milestone has been in the field since 30 years. Our mission is to reduce patient anxiety by providing pathologists with technologies for same-day diagnostic results. Today, Milestone is proud to offer innovative solutions in 6 different fields that are frozen section, cytology, sample handling, tissue processing, macrodigital, and reagents. Before we get started, I wish to inform you that Milestone organizes this type of webinars once a month, so you can follow us on our LinkedIn and Facebook pages or on our website to stay tuned. Before starting, I just ask your attention for a few seconds. In this slide, you can see the main functions of the WebEx platform through which we are broadcasting. You can notice the layout icon on the right upper corner of your screen, and you can use it to adjust your display anytime during the webinar. Also, there is a vertical line between the PowerPoint presentation and the live video. So you can move this vertical line to the left or to the right in order to make bigger or smaller the window you prefer. This webinar is intended to be interactive, so we encourage you to ask questions, and you can submit your question anytime by typing your question in the Q&A box, which is located in the bottom left right corner of your window. We will answer some questions at the end of the presentation, and for all the questions that may not be answered live, we will reply by separate email. The slides will flow automatically during the webinar. If you have any technical problem in viewing or hearing the presentation, just write to the host in the chat box and we will try to support you. Now let's take a quick look at today's speaker. Our speaker today is Marco Perrella, application specialist at Milestone Medical. Marco has graduated in biotechnologies at University of Milan, and he has wide experience in histology and research labs. This presentation today will be recorded and will last about 45 minutes. Now I think it's time to start. So Marco, you have the floor.
Good afternoon. Thank you, Michele, and good afternoon. I'm Marco, and today we will see together some tips and tricks for microtomy. Before I start, just give me a few seconds in order to share with you the PowerPoint presentation. So, tip and tricks for microtomy. We all know that is a word where the experience of the user, it is very important. But when we talk about when we talk about sectioning, okay, we have a certain expectation. For example, we want to achieve a smooth section, and not only smooth, but we want to achieve a constant quality. And for constant quality, I mean from block to block, we want to always achieve the same quality, okay, across all the blocks. And then we want to operate in a safe and easy environment. And these 3 points are not just necessary per se, but they are really important because in the end, they do have a really big impact on the final diagnosis. And we all know that the path that you might have in mind, okay, it's very different from what happened in the reality. For example, in an ideal world, you might have, the idea is to put your block and then cut it and put it on a slide. And that's what happened in the first part above, in the upper part of the picture. We all know that in the reality, a lot of things can happen between the block and the section on the slide. So, and here I've listed some of them, like under-processed sample, split and scratches along the ribbon, uneven slide, block temperature problem, and electrostatic effect. Today, I've collected some of the most common one and the one that we get the feedback the most. And I know that each one of you might have experienced with different frequency the issues that I've listed over there. So, common pitfall. Okay, so from where do we start? First of them is the compressed sections. Here you can see on the left side of the image two parallel ribbons. Okay? I've cut this ribbon, it's the same block, same temperature, but with one factor in between. Okay? You can see highlighted in red are highly compressed ribbon, while highlighted in green, there is a very smooth one. The one that the quality we want to achieve. On the right side of the image, instead, there is a similar situation, not completely equal, but where you do have compression only on one side of the ribbon, and this compression makes the ribbon bend onto the pressure plate. Let's go into have a look which can be the causes and the solutions. For example, one reason, one factor that you want to operate in order to overcome this problem is to modify the clearance of the blade angle. Here, I do have the block, the blade carrier that you can also have in the picture over there. And basically, in all the block, all the carrier, you have the possibility to change this angle. Changing the clearing of this angle have a very important impact on the ribbon, or how the ribbon get compressed. I do like this aspect because even if it's very empirical, okay, you change the angle until you get good ribbon. It has been thoroughly studied, and I'd like to put a picture from a paper from 42 where you can really appreciate all the effort that has been put in studying this aspect. So you have forces, you have angle which plays a role, even the angle of the sharp edge of the blade plays a role. And there I put also a publication if you are interested in reading this paper. The other part and the other solution for this problem can be also, of course, to clean the blade and clean the pressure plate. Here in the picture, you can see a dirty pressure plate and blade. So the paraffin itself is slightly gummy, so it's an obstacle for the ribbon to slide across the pressure plate. So it becomes an obstacle and you get compressed. Finally, a third suggestion, which is really one of the two golden rules which I would like to put at the end of each slide, is to keep your block cold. Maybe your block has become slightly warm, and that's the reason why you cannot cut it properly. Okay? Two golden rules, I mean, block cold and good blades. Those are kind of widespread throughout all the issues we are going to see together today. Then I want to analyze with you another issue which is common, split or scratch section. Here we do have similar issues, but from a different, with a different origin. On the left side, what you do have, it's a section, it's a ribbon, which is heavily scratched across all the sections. Okay? Sometimes these deep scratches become really a cut in the section, and those scratches also many times make the slice really impossible to for the diagnosis. And on the right side, you do have some section with the minor scratches, but if you see carefully, you can see that just along the block, you do have some parts which are missing. And again, let's see together which can be the causes. So in these cases, you might want to clean the blade, okay, because you might have some debris on top of it. And you can clean, of course, the both sides, or you can use a new part of the blade. As you can see, the carrier, you have the possibility to slide left and right. So you might do one part of your job with one section of the blade, and then you just slide the carrier in order to cut with the newer one. Of course, if this doesn't work, then you might want to change completely the blade. And a third suggestion, which is more related to the case that you see on the right, where you do have really the sample itself that it's really damaged, is that you are going to cut maybe an under decalcified sample. In this case, you can soak the sample in a decalcifying agent. On this aspect, I will go a bit better in detail later on in this presentation, because I make it fall under the under-processed related issues. Then uneven section. So here, again, two different situations, but this time with a very common origin. You have on the left circle highlighted in green, the good section. So flat, right thickness, and in between, you do have a highly compressed section. On the right side of the image, instead, you do have on top, close to the blade, a right section, even for thickness. Below, in the middle, a thick section, no compression, and again, as a thin section. So in this case, no compression, but different thickness. And what are the tips to overcome this problem? Is the first thing that I want to suggest is take your carrier and relieve all the leverage and tight back. So you see that you have several leverages. For example, this one is the one that binds the block to the microtome. This one is the one that allows change angle, and so on and so forth. You relieve all of them, and then you clamp it back. My suggestion to relieve all of them is only because in this way you remember and to close all of them, and none of them become overlooked. The other suggestion is that you might want to recalibrate the screws on the back, and these screws are the screws which are related to the strength which is applied to the pressure plate. So, which is this lever. They are related to the force that you apply to this lever. So, those are the two suggestions which, in a huge amount of cases, they are going to solve this issue of uneven sections. Then there is a part which is really, really interesting, which are the processing related issues. And we saw so far that all the issues that we saw together so far are really can be overcome by the experience. Now, in this part of the presentation, I really like to stress how important is the experience of the operator which cut at the microtome. On the left side of the image, you do have the hard fragment, and that we saw together before. Okay, you have just damage on top of the where the tissue should be. On the right part, we do have a basically you cut everything but the sample. Okay, you cut the paraffin, and in the middle you have the hole where it's supposed to be the sample. Tips for that. So when you do have hard fragments, and we are speaking typically about, in that case, specifically was a bone marrow biopsy, and what is very likely missing is a bit of decalcification. Okay? In these cases, what you want to do is just take your sample and make it soak in a decalcifying agent, like this. From 5 to 30 minutes might be necessary depending from the type of decalcifying agent you are using. What is really important that after this step in the calcifying agent, you are going to rinse the sample with the water, you are going to rinse away the decalcifying agent, and then of course dry it, because after this, the sample will go on the cooling plate. Okay, so you don't want water on top of it that freezes and can damage your tissue. What about the shrunken tissue? I'll let you see it again, where you have a hole in the middle where the sample is supposed to be. Shrinkage is typically due to evaporation of residual reagent remain after processing. And that's why many times you get this artifact not immediately after the embedding, but you get it the day after. The reason is because in the meantime, the reagent evaporates and leave you shrink tissues. One solution for this case is to put the cassette back in the wax bath. So you you retrieve the sample and you repeat the infiltration. And in this case, it's very useful to have a processor which can perform an infiltration under vacuum. Now, other two processing related issues. On the left, you do have a typical case when the specimen, they just jump off the block, just jump off from the paraffin. Here you can see that was a biopsy, and you have just some yellowish part in the middle. All the rest has jumped off. And on the right part of the image, you do have some blocks where is present some white areas. I'm really sure that many of you have seen these cases several times. Here you have in green a block which is completely white, almost completely, and in blue one that is a partially white. Both of these situations, I'm pretty sure you have seen it. Let's analyze a bit in detail what we can do. When we speak about a specimen that jump off the block, that just get pulled out from the block, typically indicate a lack of infiltration. And so the paraffin does not uniform distribute inside the tissues and in the cassette. In some rare cases, this is also the result, an excessive dehydration. So the dehydration impede a proper infiltration of the tissues itself. And I like also to put a slide just to give you an idea how does it look overly dehydrated tissue. You can see that has many fractures inside, and after the eosine, hematoxylin eosine staining become really purple, really high pitch pink tissues. And also I'd like to stress a bit this fact, how anyway it's important also the histology to understand what happened during the processing. However, this pulling out of a block really happened during the grossing, because really practically speaking, what happened? You are getting used to good blocks and then you gross very quickly because they are good. So the grossing is not an issue, you just quickly gross, but then at one point you get a specimen like this. So you cut it and the specimen just jump off. So in these cases, of course, it's not lost. You can retrieve that part, re-embed and cut it. Maybe just using less energy, for example. You can just try to cut it a bit slower. The other part we saw, and just to give you a visual reminder, we are speaking now about the white areas in the blocks, are often coupled with smell of clearing reagent. And most frequently, this white spot happen in fatty tissues, because fatty tissues, really for their physical properties, are kind of a barrier to any fluid penetration. So we are speaking about formalin, from formalin up to the clearing phase. Okay? So everything for everything it's difficult to penetrate the fat tissues. And another peculiarity of these blocks is that when they are put in the wax bath, they explode. We will see later on the next slide what do I mean for explosion of these slides. When you face something like that, one suggestion is to, again, to met the block in a wax bath, and then you repeat the impregnation phase according to their thickness. And if this doesn't work, a reprocessing might be necessary, because maybe are some previous steps that are still missing because of this physical barrier that the fat does to fluid penetration. This slide allows me to introduce the exploding section. Okay? This is a typical exploding section. This picture in particular, I've tried to cut one of the two blocks I've shown you in this presentation. Few seconds in the water bath, and that's what happened. You have a smearing of the section all across the water bath. So tips for this case. Okay? Typically, this explosion of the tissue happened from underprocessed tissues. But if everything looks right, okay, simply properly processed, for example, and this might point out that the water bath is too warm, has reached a highest temperature, too much higher temperature, sorry, for the paraffin that you are using. And in brackets, I put like a statistically average temperature of the water bath you can use. And also, this aspect allows me to introduce another danger, which is related to the water, this explosion of section, which is the source of floater and contamination in your slide. You can easily imagine that if you have a section that smear across the water surface, and then of course you have to cut and use the same water for different slides, some fragment of the section which has exploded might end up in your slide, in the next slide. Below, I put another interesting paper where is here you can see those contaminants in the histology, in the slide histology, and also put the reference. This is very nice. They quantify the risk of contaminant in each of the steps of the histology processing. Now, together we saw how is important experience, your experience in overcoming such problem, but in order to get a good slide. But of course, the other factor which plays a fundamental role is the microtome. Because in the end, if you have a skilled operator like you are, but you are not having the good companion for your work, that's what happened in the first image. Okay, the man is clearly highly skilled, but is not getting the right tool to complete the job. Okay, so no success. On the right path, right skill, and right instrument, you are getting the job done. You are getting a ribbon. So how to choose the right microtome? What are the important features? It has to be easy to use. It has to be intuitive, safe, flexible, and reliable. Now let's see together all these features. Where do they are positioned in our microtome? So easy to use. I get a bit closer to the microtome. Sorry if I pass in front of the camera now. And so a fundamental part is the hand wheel. We are speaking about a task which takes hours. Any operator sits for several hours cutting blocks. So, and having a smooth wheel is really important in order to have not to have a physical fatigue, not to be physically stressed. Then you do have spacious tray to collect all the residual from paraffin, and anti-static coating, easy to clean. And now that since I was really speaking before about the contaminant, having an easy to clean surface is really important also to decrease the amount of cross-contamination, because here we are cutting hundreds of different blocks. And then, of course, it's made to have a lot of room to display your instrument. Here we do have a blade, brushes, forceps, and so on. You can store it easily on top of it. It has to be intuitive, of course. Here, the touchscreen is positioned in order to be very comfortable to operate, and then you can easily access all the functions just by touching the button on top of the screen. You can really easily switch from cutting to trimming, and you can decrease or increase the thickness, for example. Then, of course, since it's a semi-automatic microtome, you have the possibility to select many cutting parameters. You do have the memory function, which allows you to come back at a predetermined position when you move from one block to another one. And then the retraction function, for example, when you come back, when the head come back from the block, in order to not to consume your blades too much. So it's designed for safety. You have, for example, you have here the finger guard, which protect you from accidentally touching the blade. And so it also has been developed a very easy way for removing the blade. Just remove the finger guard, relieve the clamp, and then you can see how easy it is to remove the blade. Okay? Then you can imagine this is a new one, and you just position here on top and just lock it. Now I'll take it out. And then you do have a manual lock. Here we speak about safety. Here the hand wheel can be locked at any position. And you do not have to target a specific position in order to stop the head from moving. And then, of course, it's also made very stable with a heavy base in order to overcome any sign of vibration. Then, of course, it has to be flexible. Here we have the head, has to be, and now this is the head, which is typically equipped on this on the histodream end. It's just enough to pull this lever, and then you can take out the block, change orientation, and so on. Easy to remove means that easily you can take it out and put the super mega. This is also what I mean for flexibility, that quickly you can switch from one configuration to another one. Very easily, I can put back the block. Now, so far we saw some issues, let's say, where the operator with his experience, can overcome such problem. One other problem, which the operator cannot overcome directly, is the statics. Statics is the effect, the physical effect, where you have the ribbon, which is really sticky. And sticky means that when you cut the ribbon, you will have the ribbon you will have the ribbon which attached to your finger or attached to the block itself, like it is shown now in the presentation. And here on the left, you do have an explanatory picture. What caused the statics? Statics is given by the friction between blade and blocks. And this friction, of course, caused the ribbon, the section, to be electrically charged. Milestone has developed the EasyCut, which you can see here on top, and you can see also in the picture itself. That is an instrument which flushes the instrument, the microtome, with the ionized air. Okay. This ionized air make possible to neutralize the charges on the section. In order to show you how does it work, I have with me today, I prepared a very simple experiment. I'm sure that all of you have done sooner or later, maybe even at school. Here, I do have these plastic sticks, and I just let it charge by rubbing it on a paper. I will just stroke it on the paper in order to make it charge. Now, I will also have here some paper fragment, and you can see, get a bit closer, how all of them get attracted. So I even open my shirt so you have the darker background, and you can see how they are attracted to the sticks. Now, I will repeat the same action, but this time turning on the EasyCut. So the EasyCut now is flushing the entire surface with ionized air. Now, as you can see, I'm charging the stick, but this time, while I'm speaking, I'm letting the ionized air acting on the stick. So in this moment, this stick is your ribbon, is the surface of your working area. So now is completely under the effect of EasyCut, and you can see that you cannot attract any paper. So that's the effectiveness of the EasyCut in neutralizing the charges. And then, of course, also provide you also a very comfortable light environment for cutting. Because we always have to remember this takes hours of your working days. Now, another point, which is also very important, is how we maintain the traceability in these final steps of the histology process. And before, I've discussed with you a topic which is really important to me, which is the experience of the operator. And in this moment, I am the operator, which I've seen something weird. Okay? This is basically the block you can see in the picture. I see this block, I see that it's very hard to cut, very dried, and I want to understand something more. What happened before this block has reached my hand? And in order to do that, Milestone has developed the tracking system for the embedding steps. Okay? Here you can see the embedding steps before. And this is very important because all the information that you are going to retrieve, you can have, with all the information, you are going to see the entire story of the block. So now, by simply scanning the barcode here on top of the cassette, then you are going to see the picture on the tracking device. Okay. Of course, this supposes that you can see that this is the same block I'm showing you here. Okay, so if now I am the operator, not only I will discover that something weird that happened, but I also discover that in the beginning the blocks were 2 and not only 1, as I have it now. So this is what I mean for the traceability. This is a powerful tool to understand the entire story of the block. Of course, this system is a part of Microtomy. Okay? If you do the grossing with Microtomy, you can document everything. And in each moment, with each block, you can retrieve the entire story of your sample. With this one, I conclude, and I'll give you all the time to make some questions. In the meantime, I'll switch to the camera.
Thank you, Marco, for your presentation. I have already collected some questions, so I'm gonna read them to you. In the meanwhile, if the other attendees have other questions, just type them now in the Q&A box. So Marco, first question is, you said that one of the main sources of contamination is the water bath. Which are the other ones?
Yeah, that's a good question. And also this topic is deeply analyzed in the paper, which I've shown you. And basically, one source is the water bath. The other one are the fragments that you have on the microtome itself, where you cut several blocks, many blocks of different nature. And that's also why I'd like to stress how it's important to have an anti-static coating on the microtome. Another aspect which is mentioned very often is the staining procedure. Okay, you have a slide which run across several steps of staining, and that's also is a source of contaminant. So my suggestion always to keep water bath, microtome very clean and change as often as you can the reagent for staining.
Thank you. Another question is this one. Do you have any suggestion for the additional decalcification for samples?
Okay. My suggestion, like in this case, the case I represented over here, is to use like ADTA-based decalcifier, such as Moldecal. Because in the end, when you do a step like this, what is necessary, what you need for, is just to get some sections and good enough to to do the diagnosis. So you are not getting the entire decalcification. And like EDTA based would do the job, and it's even less toxic, of course. And plus, a strong acid, they have the risk that they are going to spoil the morphology of your cells. So go for EDTA based decalcifier.
Okay, another question. What to do in case of chattering Venetian blind effect in sections?
Okay, chattering may arise from different issues. I'm speaking about micro chattering, and many times, of course, is first things you have to check is it everything tightened? Okay? Even in that case, is the block very well fixed on the head? But also can be that the block is very hard because of temperature. So just wait a few seconds just to slightly warm it up and try to cut it a bit slower than what you're doing. And that would solve many times the problem. Sometimes also the sample is very hard. So there are some procedures in order to slightly rehydrate the sample. Even some of, I've seen many times using chilled water to slightly rehydrate the surface. And this might overcome the problem.
Thank you. Now a question about the microtome. Can you explain a bit more the function of the 3 screws on the back of the blade holder?
Sure. So I'll just remove it for easy of use. And you mean these screws over here. So this is the lever which basically clamp the pressure plate onto the blade. These 3 screws, and now I take as a chance to show you how to dismount the carrier. They put pressure on these 3 segments. Of course, the pressure on this segment must be equal, but they really play a significant role. The more you tighten these screws, the more pressure they apply on this lever. So once I take out this lever, I can also show you how to open the pressure plate in order to clean it properly. And once I'm here, I can also show you that here you have this small bar, steel bar, and if you remove it, you can switch from high and low profile blade. So I take it out, and now with the same instrument, I can also work with a high profile blade.
Okay, I have another question which may be slightly off topic, but I'm gonna read it to you. Does the embedding station has an automatic or programmable start? And what is the recommended temperature for the cold plate?
Okay, so this embedding station, the Histology EW, you can program the start of the start and the end of the working day. So for example, start of the end working day, but even holiday. So everything will be shut down, but still you can have the paraffin melted, paraffin which is stay under the screen here in the middle part, because it's always important to have the possibility to have the molten wax in case of emergency. Okay, so you can program. The temperature we do suggest for the block is between, it's roughly minus 11, 12 degrees. That's a good temperature to operate.
Thank you, Marco. Now I see that time is running out, so for all questions that have not been answered live, of course, we will reply via email in the next days. Now let me share with you one final slide, with few information. So if you have any question left, or if you want to receive any material from us, please, you can see our contacts on the slide here. Our application team is always available to plan and organize virtual customized demo. So if you need a demonstration, consultation, or solution, you can contact our application team for a live demonstration. Starting from tomorrow, this webinar will be available for on-demand reviewing, so you will receive an email message when the webinar is available. If you wish to keep up to date with Milestone new live events, we suggest to check our website and follow us on our social network. Next educational webinar is scheduled on the 28th of October, and the topic is auto-embedding. Registrations are open, so you can already book your seat for the live event. Thank you, everybody, for watching and participating today. Thank you for your interest, and we hope to see you all next time. Goodbye and arrivederci.
Goodbye.